Boy, I need a haircut, boy. Need a haircut. But the maths must go on. Haircut or no haircut is maths. So what you should be seeing on this slide right now is 12 p.m. to 12 a.m. tomorrow. Please go there now. We're doing the 12-hour session. So those of you all who still probably trying at the last minute to get into the session, the number flashing underneath the screen there, we had to try and do it now so that the admins will get time to process your registration and you'll get time to jump in, right? So we're doing a 12 to 12. That's a crash course. Crash course. 12 p.m. to 12 a.m. PM, AM. PM is the middle of the day. That's happened to anybody sometimes. 12 p.m. is what again? 12 p.m. is the middle of the day and 12 p.m. is the middle of the night. The AM, PM thing can get mixed up sometimes. So we will be grinding through. We will be grinding through that. I'm looking forward to that. I hope I can get in some good sleep tonight so that I'll be fresh. Well, it will be me and Miss Nalini. She's a teacher in the student hub, another maths teacher. Some of y'all who are in the student hub, once in the student hub maths classes, you'll know about Miss Nalini. The incredible Miss Nalini would be joining me on that. So let's just jump right into today's class. Today's class is the final class in the series that I did. I did 10 classes, 10 sessions on each question in the CSEC Maths exam. Excellent session. How many of you all were there in all of these sessions? How many of you all were there in all of these sessions? You should be seeing this question here. We're gonna do this last bit was vectors and matrices. So just a little recap on what you can expect in your exam less than a week away. Let's go to slide 3. Here's what you can expect in your exam less than a week away, right? You'll expect 10 questions, question 1, question 2, question 3, question 4, question 5, question 6, question 7. Yeah, you start to get tired when you reach the 8, question 9, question 10. 10 whole questions you have to do in the maths exam. Where is section 2? Section 2 is this bit, question 8, 9, and 10. So this is section 1. Section 1. And this is section 2. And section 1, well, of course, you know, you start off with what? What do you start off with? Computation, numeration, as the first day, consumer arithmetic. Well, the easy stuff, right? The fractions thing, standard notation, scientific notation, different forms of approximation, higher purchase, simple interest, compound interest, taxes, percentage loss, percentage gain. Sometimes some algebra, which comes in this question, is meshed into that question. In question 3, it's mostly geometry. Geometry in its different forms. So you can see geometry, construction geometry. You could see some shapes stuff. Maybe you might even see some Pythagoras theorem sneak into question 3. Sometimes even they kind of merge question 3 and question 4. They kind of blur the lines between it because question 4 is more relations, functions, graphs. Relations, functions, and graphs. Out of all these first 4 questions, how prepared are you? So these are the 4 easy questions in the paper. Supposed to be the 4 easiest questions. Sometimes it could be a little tough. Relations, functions, graphs, coordinate geometry as well. Question 5 is almost 100% always one full question on statistics. And statistics is usually cumulative frequency, but sometimes you could get stuff on high, what I want to say, histogram, bar graphs. I don't make sure and sleep tonight, but because anytime I'm forgetting words is because lack of sleep. Pie chart, line graph, frequency polygon. But I mean, I can do maths with my eyes closed, so be safe. Statistics. So one of those things will come, and of course, they'll finish off with something on probability. And question 6 is usually a measurement question, one big long measurements question. Measurements, man, just excited for to do that today, this year. And of course, question 7 is an investigation question, but it usually is something on series and sequences. And we did a bunch of those, and I showed you all how to conquer it, series and sequences. So the mark allocation is that these first 6 questions are worth 9 marks. I write 9 and 9 marks. And it's 6 questions, so 9 6s are how much? 54? 54 total. And the last, this question 7 here is usually worth 10 marks, so that brings it up to 64. And then these 3 questions in the end at 12 marks each, that's 36 plus 54, so the entire exam is out of 100. So you have 64 up to there, 54 up to there, and 100 up to the end. So 12 marks each in the last questions, the big boys. I see people only talking about big boys on Instagram and things since I say that so much. Anyhow, so the question 8 is relations, functions, graphs, coordinate geometry again. But it's the more intense parts of it. So you may see completing the square, you may see high chance of completing the square, linear programming, you may see speed time graphs, that kind of thing. Question 9 is circle geometry and tougher trigonometry. So in the trigonometry, you'll see bearings or angle of elevations. And in question 10, we have, which is what we're going to do today, vectors and matrices, always vectors and matrices. So I made a video on TikTok and it got like about 200,000 plus views, I think. And I showed you all how best to go about this for the last few days. If you're cramming off and you're just using your past paper and you just, your textbook and you're just cramming. Well, if I were you, I would do question 1, 2, 3, 4, a bunch of those, especially algebra, a bunch of those. You have these solutions on my website, right? KevinSpringer.com, solutions typed up nice. So you go and get all the past papers and you do a bunch of question 1, 2, 3, 4, and make sure you do most question 2s as much as possible because they're highly repetitive. So you do that like for a day straight. And then I would go to this topic. This is good marks. The things that I would leave for last is question 8. Because if you know question 8, like if you're cramming, right, and you know question 8 yet, it could confuse you. So leave question 8 for last. Question 7 is a question you need to jump into now. Like now. If you don't know your question 7s and your series and sequences, the pattern stuff you're doing like 2-3 days ago, learn that it's very, it's highly repetitive. Definitely vectors and matrices. Definitely matrices, very repetitive. And then you start to go into the others. But this is the layout here. You get to see how the marks allocated. And you're doing as many past papers as you can with as many solutions as you can. Just one more thing. So let me just include one more slide next to that, where I just tell you how the marks is. I want to show you a road to victory. Let me call this road to victory. Are you paying attention? How many people in the life? Road to victory. I'm going to draw a little road too. I'll give me 2 minutes to draw a road. Dun, 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 dun. Students in my class know Israel draw a road. Dun, 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 dun. That's the bush on the side of the road because it's a Trinidad road. Maybe I need to put potholes in this road. I'll give me a little second and I'll put some potholes in the road. The road in Trinidad. One more thing, let me just put some lights on the road. All right. This is the road to victory, people. So here's what here's how the mark allocation is. The mark allocation is that paper 1 is worth 30%. And paper 2, which is what we have been studying these last 10 days, is worth 50%. And paper 3, aka the SBA for most of y'all, is worth 20%. So I just answered a question on Instagram. Somebody said if I get total in the paper 1 and I get total in the paper 3, total in the paper 1 and total in the paper 3, you think they have total in the SBA and total in the paper 1. They ask me if they fail paper 2, if they think they can pass. And the answer is yes. You know how much people that happened to? You know how much people in the years gone by have completely failed this paper, meaning out of the 100 marks in this paper, they must see, when they work it out, they see 40 out of 100. But then when they went and checked the results, they got 2 or a 3, it could happen. So, but make sure your aim is to try and scrape as many marks as you can in this paper. Do not give up. When you're doing that exam next week, don't give up. If you reach like the 4th question, 5th question, and you find it real hard, keep going. Make sure you check every single part of the question, because you want to get as many marks as you can in this paper. Because when we start to vibe the paper 1, and we can do a little paper 1 too, because paper 1 is not the same day. So we are going to do some series on paper 1. I hope you're ready for that. When you start to vibe it, you'll start to realize that the paper 1 is possible even for a weak math student to get close to total. So it's possible that you get close to 30% here. And let's say you get 20% in this paper. There's the road to victory. Let's say you even got 20%, which is failing this paper, because half mark is 25% out of the 50. And then in your SBA, let me say your teacher was nice and you get 20% in the SBA total, or 18 lowest. Some of y'all must be 16, but that kind of low. But hopefully you get 18 and above. Add up all of this and tell me what you gain. 70%. So give or take a few marks lost in the paper, one or a few marks lost here, and maybe you get a little higher there. You see how you could pass maths, even if you do kind of bad in the paper too. So if you see the way type, I see the way. I see the way. There have been many students over the years. Go and check my past students them. Those are them who are suffering in mathematics. We show them the road to the victory. And hey, just so the camera cut off. We back? Yeah, we back. and they get through, and now they join the police, and they join the army, or they join nursing, and they went on to do further things with their life. What you don't want to do is not, well, fail. You don't want to fail, and then you have to repeat here and repeat here. But if that happened, okay, it happened, right? You learn from your mistakes, but just trying to show the road to victory now. All right, so you're seeing it? You're seeing it. Real people seeing it. Nice. So without any further talk, I think we're ready to do the question now. That's real talk, boy. Find the product of AB. AB. That's multiplying. And in matrix multiplication, it's kind of work like this. It's be kind of sliding along. It's a dance. So A is M1, -1, 2. B is -3n. So when you're multiplying in matrix, yes, you multiply the row by the column. This with this, and then this with this. So you're sliding along the row and you're sliding down the column. So in the end, you should end up with -3 by m, and by -3 is -3 by m, and then you're adding that on to 1 by n. If you don't know matrix multiplication, look up my video on it. -3 by -1, -1 by -3 is +3, and then 2 by n is 2n, and that is a d. That is a d. Notice how it have m's and n's and thing in it, so we couldn't go any further than that. And then find the values of m and n such that when we multiply, this is equal to -9. So they're saying if AB is really equal to -9, then what we just got, -3m plus n and 3 plus 2n should be equal to, if the screen is blurry, what you need to do, somebody type it out if the screen is blurry for them. All you know is how people is coming and the screen is blurry, so they can just let them know, right? -9, 9, very simple. You could raise the settings, raise the resolution. So it equal, and then you say therefore, and you can separate it, -3m plus n should be equal to -9. We can't do nothing with that. So you have to go to the next one. You just call that equation 1 for now. We can't do nothing with that. Why we can't do nothing with that? It have an m and an n in it. The other one is 3 plus 2n is equal to 9. We could do something like that. We could say, well, 2n is equal to 9 minus 3, which is 6. And then n is equal to 6 over 2. So we could figure out what n is here. So now that we figured out what n is based off of that line, right? Now we figured out what n is, we could say, well, back from equation 1, -3m plus n is equal to -9. But we know what n is. N is 3. So is equal to negative 9. So if I bring across that 3, I get negative 12 is equal to negative 3 by m, which means m is negative 4. Because if I bring across the 3, I get negative 9 minus 3, which is negative 12, right? I kind of skip a line there. So m is 4. And you can verify. You can verify. Negative, like if I put back the 4 here and I put back the 3 here, negative 3 by 4 is negative 12 plus positive 3 is negative 9. All right, so we finish the first part. Let's go on to the second part. Solve the following pair of simultaneous equations for 3 marks. But they want you to use a matrix method. So I'm glad the question does give you the whole thing straight up matrix method. So let me go on a fresh clean page. Let me make a page in between us there where I can do that by right here. So, and I'll write back you could give me the, oh, I make an extra page by accident. Let me delete it. So you could write back I'm going to write back the 4x minus 5y equals 17. So you're going to get to see this whole thing. 4x plus 3y equal 9. 4x plus 3y is equal to 9. Right? And you're going to get to see me put on a good piece of work here. So using our matrix method. Using our matrix method, right? Here's what we had to do. In matrix form, that's the equation. I'm going to bring out the next color and them there. Bring out the blues and them. In a matrix form, this would look like you take the coefficients, you take the xy, and then you take this column matrix here. So how do you fill out this? Well, each number here going in the first one. So 4, negative 5, 4, 3. You put in the x and the y here, that's the variables, variable column matrix. And then these numbers go in there. That is actually a mark. So 1 mark done locked down there. Be in the game. And now in the inverse part is a mark. So this is usually a mark. I don't know how they else dice it up. So the inverse part is that this matrix is of key importance to us. So you could write the poem now where the poem is in the form. This is in the form A by capital X representing that, A representing that, you understand? Equal, and you can say B or K or whatever you're feeling, B. So to figure out what X is, you need to bring across the A, and anytime you bring something across, it turns into the inverse. But you have to put the A inverse in front. So we need to find A inverse. We need to find A inverse. So how do you find A inverse, folks? How do we find A inverse? Well, to find A inverse, you need to find the determinant and the adjoint. So finding A inverse, you have the determinant. Let me get back to my normal pen, please. The determinant of A is equal to AD minus BC when A is in the form A, B, C, D. So the determinant of A would be, just verify that these numbers I picked are correct, 4 by 3 minus negative 5 by 4. This is 12 minus negative 20. Why this turning out to be such a big number? 4 by 3 take away 5 by 4. I hope I didn't make any mistakes here. So this turning out to be some big kind of number of 32 or something, like the determinant or gate. And then the A, the adjoint, let me just see if I can do. So normally I have a kind of setup for this now, and I don't want to change it or everybody to learn it that way. I want to do the determinant on one side. So when A is this, and I'll do the adjoint on the next side like this. The adjoint of A is, the adjoint is at another matrix. So you swap the A and the D and you switch the sign on the B and the C. So the adjoint will look like this. I'm going to put the 3 here and the 4 there, a swapping. Excuse me. And I'm switching these signs. So this is -5, so it becomes +5. And this is 4, so it becomes -4. And now, A inverse is equal to 1 over the determinant by the adjoint, which is 1 over 32 by the adjoint, which is this 3, 5, -4, 4. So this is something you have to take your time and learn. And I'm leaving that just so, because, again, look at that. I'm not going to bring that 32 into them numbers. That could stay just so. And then we need to find, so we're picking back up now. You ready to pick back up? Look at your neighbor and say, time to pick back up. Time to pick back up. How are we going to pick back up? Well, X is equal to A inverse by B. So X is equal to A inverse by B. So A inverse is 1 over 32 by 3 by 5 by -4 by 4 by B, which is, B is, what is B? B is 17.9. B is this matrix here. So we have to multiply. Why this thing so long, boy? We have to multiply. And I'll leave any 1 over 32 still, because I 1 over 32, you know. By the way, X is really standing for XY. 3 by 17 is some number, and I need to add it to 5 by 9. Right now, like I all out of gas for this 3 by 17. So 3 by 17 is what? 51. 3 times 17 is 51. 51 by 5 by 9. So 51 plus, because you're multiplying, right? 3 by 17, and then 5 by 9. So 45. And then -4 by 17, which is 68, -68 plus 36. So 32. So right now, so far, I have 1 over 32. This will work out to be 32, the bottom number. And 51 and 46 is 45 is how much? 96. 32 could go into that too. How strangely convenient. So normally it works out really convenient. So this means XY is 1 over 32 multiplied by them two numbers. You see why leaving out the 1 over 32 work? All you knew that trick? All you know about them things? Things are showing all you know, things. And then this is equal to 96 divided by 32, which is 3. And then 32 divided by 32, which is 1. Therefore, X is equal to 3 and Y is equal to 1. That's a bunch of work for 3 marks. Ta-da! Well done. So how good are you all in that? You can keep up the question. How good are you all in that? Me sitting is oh, I made a mistake. I'm seeing -68 plus this is -32, so this is -1. -1. -1. Rate it out of 10. So what you could do to double check that your answer is correct, I'm about to show you some things that is on my channel, and I've shown my students a lot of tricks. You could bring this overhead camera alone, or with this calculator. If you press shift, if you just press mode, and then you press 5 for equation, and you press 1, like simultaneous equations is set up there, now, believe it or not. So what's the numbers? The numbers was, you can see it, the numbers was, 4x minus 5, right? So what you really want to do is paint the coefficients. So I'm going to put 4, see now? I put -5, then I put 17. So this is useful for you to verify the answer. Because look at all our work we do. To do all our work and lost out because some point, some negative or something mess up is failure. So let me just double check and make sure that we're on the path of righteousness here. And then part 9. So I literally put in all the coefficients. Now I press enter. And they tell me X is 3. And you know how good you're going to feel in the exam when you see that? Boy, your pause going on erase. And Y is -1. Y is -1. I press equal again and show Y is -1. So, and you can keep pressing equal to cycle through or to fix any mistakes you make. Most calculators could do this and people don't even know. So, all right. If you want to know how to do it on the sharp, just search Cohen-Springer sharp simultaneous equation. Let's go on to another question. Let's see if we could sneak in the next question. Part B. with respect to the origin, I like that question. It tests a lot of different things. With respect to the origin, you position vector A and B of A and B. OA is this. You see now? And OB is that respectively. The D and E are placed. The D and E are placed on A and C and on AC and OA respectively, such that AD is half AC. So this splits it into 2 equal parts, right? And OE is a quarter of the entire of O to A. So how many parts should we have here? If this is a quarter of all the way O to A, it makes sense that I should split it into 4 parts like this. So I'll just do that to keep it in my mind. And now we need to express the following vectors in the form AB. The form AB. So A to C, you want A to C, that. A to C, folks. A to C. A to C. Can we get some A to C? So to go from A to C, the key to vectors is finding another way. So if we want to go from A to C, we can go from O to B. I am drawing the wrong thing. I phasing out here. A to C is this. You want A to C. My bad. And 1 mark. So I guess I could have just put 0, 6 and get the answer and get the full marks there now. But anyhow, so A to C. How do we get A to C? Have a few ways we can do this. This question can be conquered by using the triangle law of vectors. And I don't feel, to be honest, I'm feeling like I want to teach you again. I teach you triangle law for vectors enough time on this channel. So if you want to see what the triangle law is, you have to do some research. Just search Kerwin-Springer vectors and the videos that I have on vectors. Good thing, good thing. So AC is really A to C is really if you want to show them a little calculation now, O to C minus O to A. And you have to research why this is so and how to know how to do it, right? So O to C is really the position vector. So it will be 12, 6 minus, and O to A is the position vector of A, which is 12, 0. So in the end, you get 12 minus 12 and 6 minus 0. So A to C is just 0, 6. 0, 6. Got it? What is O to D? So we need to find middle of that. So we can do this because I want to show working now. Because I mean I know O to D is 12, 3. So 12, 3 is the answer since it's in the middle. But I want to get them a little extra sauce and I get them working. It's in the middle of this and it's on the line. So but so I can say that A to D is really half of A to C, which is half of 0, 6, which is 0, 3. And O to D is really like if I went from O to A and then I went from A to D. So O to A is 12, 0. Seen it? A to D is 0, 3. I just worked that out. So when I add the two together, I get 12, 3. How is that for you? Rate out of 10. And let me see if I can go and get a next slide to. Oh, you already putting the next slide for me. Number 7. Let's see if I can put in. Let's see if I can do the last part, BE. So BE. They didn't say anything about drawing line or anything. You don't need to draw a line. They just want to work it out. B to E is what? Is this? So B to E come like if I go down this, so it'll be negative, and then I go across here, so it'll be positive. So I'm going to work out what O to E is. O to E is 1/4 of the way of O to A. So it's going to be 1/4 of 12, 0. You notice how I just taking this and putting it in a vertical format, changing the coordinates to a position vector. That's how you do it, which is 3, 0. And I already know that BO would be negative OB. In other words, it will be negative 3, negative 6. Not so? Negative 3, negative 6. So B to E is like if I went from B to O, and then I add that to an O to E. So I'll get negative 3, negative 6, plus 3, 0. So what would you end up with? I will end up with negative 3 plus 3 is 0. Negative 6 plus 0 is negative 6. So it's basically telling me I just need to go down 6. Now, all of these questions, I could just watch the diagram and state the answer, but I want to get them a little working, and I also want to show you all that method, just in case. Now, boy. So let's go on to the next slide. Consider the following matrices. We have A, we have B, and we have C. Find the determinant of A. So you hit medium lines A. The determinant of A is equal to AD minus BC when A is in the format of A, B, C, D. So in this case, it's 3, watch the numbers, and see if I'm mapping them up correctly, minus 6 by 1. How many of you already have any live, right? How many should I in live? This is negative 6 minus 6. This is negative 12. How much you have? 430 something people here. Big up all yourself. Here, it's a long time we do the screenshot thing. I don't know if you're still on Instagram. How much are you still on Instagram? Take a screenshot now. Let me. Hi, Instagram. And share on your Instagram, D. And we live. And maybe some more people will come on and jump on and start to study and thing. You could feel free to tag me. Tag me at Kerwin Springer on Instagram. All right, I'll just now. Let me get ready for the picture. Right. Ready to go. Ready to go. So let's. What is undo? Right. Is the matrix A singular? Justify answer. No, it's not singular. For a matrix to be singular, the determinant must be equal to 0. So A is none or non-singular or not singular, since the determinant of A is not equal to 0. So if you're not on Instagram, do go and add it back to do that, and next thing you get distracted. But if you're on Instagram, feel free to tag. Suppose that A, B is equal to C. Determine the values of X and Y. Okay, fine. So they're saying that A, B is equal to C. So let me set up that dynamically. I want to put A, 3, 6, 1, negative 2, and I multiply by B, X, Y, and I'll equate it to C, negative 3, negative 3. But if I multiply A by B, I will get 3X plus 6Y. So far, so good. And then I get 1X, which is X, and then minus 2Y. And that should be equal to negative 3, negative 3. I don't want to do that. It's a simultaneous equation. I don't want to bring it back into simultaneous land. So I go and do this whole simultaneous thing again, boy. Let me see. I'm going to speed through this time, right? In the form AX is equal to B. Therefore, X is equal to A inverse of B. So we need to find A inverse. I took my time on it just now, but I want to go faster now. So the determinant of A, already know the determinant of A. Determinant of A is negative 12. And the adjoint of A is negative 2, 3. You do the swap and then you switch these signs on this diagonal. And therefore, A inverse is 1 over the determinant by the adjoint, which is 1 over negative 12 by negative 2, negative 1, negative 6, 3, which is, leave that just so. Remember I tell you don't interfere with that? Leave that just so. And then 1x. So x is really equal to 1 over negative 12 by negative 2, negative 1, 6, 3 by b. But b is negative 3, negative 3. 2 negative 3 by c, Well, I bet in the form this and my b was that. I could have very well called this c to make my life easier so that nothing ain't looking too confusing. So let me put this as c. And then I need to multiply these two matrix down in the hole here. So let me just see if we could do that real quick. So we have negative 2 by 3 is 6. 6 by negative 3 is negative 18. Negative 1 by 3 is positive 3. And 3 by negative 3 is negative 9. So in the end, when all the dust settle, this is giving me x is equal to negative 1/12 of negative 12. And 3 minus 9 is negative 6. So x, we get in values of x and y. Remember, x is the big matrix standing for x and y of 1.5. Negative 12 by negative 1/2. That's why I'm make sure my calculations correct here. I just need to watch for the negative numbers. That's why I want to take a little check back for. Negative 2 by negative 3, 6 by, yeah, so negative. Both of them turn out to be negative. So both of my answers positive. Because I have to multiply by a negative on the outside here too. Yeah, so both of my answers positive. Are you get that? We could go and double check again with our simultaneous equations calculator things. Look, I don't have it load up here, so I could just put in things 3, 6, negative 3, 1, negative 2, and negative 3. And I'm gonna make sure I don't make any mistakes with them signs. Negative 2.5. Why I get negative 2.5? Did I make a mistake? 3, 6, negative 3, 1, negative 2, negative 3. Negative 2.5. So I make a mistake somewhere. So let's see if I can find where I make this mistake. 2, 3, 6, 1. So I get the half. So we're going on with my negative 2. Was this supposed to be negative as well? Negative 2 by negative 3 is 6. Pin by pin. My determinant is correct from before. My adjoint is looking good. I find everything I have here looking good. 3, 6, 1, negative 2, negative 3. This was 3 and 6, so negative 6. This is negative 6. Lad, you see one negative sign I leave out there? One negative sign you leave out here. So you're not locked in, you're not focused, and you're bringing this down and I leave out a negative sign. Wow. And let me see how that would affect my negative 2 by negative 3 is that. I'll get plus here. So I know it was something to do with this because it's supposed to be 2. So you see why the calculator check over helped me. So this was supposed to actually be 24. I sell a that calculator check over there. And you get sold on that. So you get negative 2 here. Yep. When I was bringing down the negative 6, I leave out this thing. That's happen when, as a teacher, when you're talking and you're writing, sometimes you just forget out things. So like if you're distracted when you're doing your exam, you could forget out all the negative sign and thing. Let's go on to the next question. So the figure OPQR shown below is a rectangle. OP is X, OR is Y. OPQR. Oh. Well, you know Q had to go there and R had to go there in case you're frightened. It had to go in a circle, OPQR. And OP is X and OR is Y. Right? O to R is Y. So I could put a little arrow there to just make sure we know what we know. And the point A lies on PQ such that PA is 1/3 the distance PQ. So A is about here. So if you split this into 3, guess who they? A. That's A. Good, good. And the point B is the midpoint of QR. So B is over here. Why isn't the chat if you understand everything so far? Complete the diagram to represent all the information above. I did that. That has been did. Complete the diagram, right? So given that OA plus OB is equal to K1. Oof, what in the world is this? I feel like I never see this before. X plus K2, Y, where K1 and K2 are constants. Use a vector method, find the values of K1 and K2, yes? So they want you to find the numbers in front of you want you to find the values for the X and Y coordinates. Well, this X here is really like a I, and not simple is really like IJ thing they're trying to do here, right? Okay, in other words, they're basically telling you what is OA plus OB. So we need to find what OA is and what OB is at the end of the day. OA is, let's find it in terms of X and Y. Well, X and Y is not IG. X and Y is these different things here. So I kind of say that a little bad. OA is, tell me if you agree with this. O is the same as going from O to P. Remember the key to vectors is finding another way, and P to A. So OA, excuse me, O to A is like if I went from O to P and then P to A. Yes, class? So O to P is X and P to A is 1/3 of the way from P to Q. But P to Q is really Y. So 1/3 Y. How is that so far, class? How is that so far? And O to B is, if I went O to R and then R to B. O to R and then R to B, RB. O to R is Y and R to B is half the way of the ups. The ups is the X, so half X. And now we say OB plus OR, OA plus OB, sorry. OA plus OB is like if we add the X plus the 1/3 Y plus the Y plus the half X. All right, so this is like terms games. This is the like term game. So we have a X and we have a half X. X plus half X is how much X? That's 3 over 2X, so 1.5X. You don't know decimals in this, eh? And then 1/3 Y plus Y is 4 over 3Y. Are you catching that? Is that making sense? OA plus OB. Yes, it is making sense. OA plus OB. So we add the X's and we add the Y's. And then this is in the form K1X plus K2Y. So therefore, K1 is 3 over 2 and K2 is 4 over 3. What a creative question. Just to make you add some vectors. Very simple. Very simple. And we're moving forward. Should we move forward? Because I have things to do now. Only one more? What are you thinking about these questions? So we just do two. I think we do two, and we get to see a good bit of different things here. One more. Yeah, boy. This is the big boy questions for a reason, no? This is the big boy questions for a reason. So slide 10. Given that OA is that, AB is that, and CB is that, find OB. OB. All right. Well, here's the triangle law. AB is really OB minus OA. So if we rearrange, OB is really, you bring across the OA, gets in positive, is really OA. And then you pick back up on A and you go to B. Makes sense. O to A and then A to B, right? So OA is 2/5, well, negative 2, 5. Now, the key to this is knowing what vectors is about. So if you don't have any clue on what vectors is about, it must be looking hard. But the stuff that I'm doing here is not too hard, and not too hard at all. It's just I don't know what vectors is about if you find it hard. So negative 2 plus 2 is 0, and negative 5 plus 2 is negative 3. There we go. And is OB parallel to CD? Justify your answer. So OB is like if you go negative 3 down, right? 3 down. 3 units down. I just gain a visualization method here, but I'll show you the way to write it. And CD, this is OB. CD is 0, 9. That's like if you go 9 units up, but you have 0 on the X, so you're not going. So you can already see that these things parallel. Both of them are vertical vectors. There's no X component in them, so they're parallel, yes. But the way to show that they are parallel, you could say that CD is equal to, and 9 divided by negative 3 is how much? CD is negative 3 times OB. Tell me if you agree with that. If I multiply OB by negative 3, I will get CD. So because they're related, and this is the magic word here, by a scalar factor of what? Of negative 3, they are parallel. The vectors are basically multiples of one another. And that's how you prove parallelity, parallelism in mathematics with vectors. It's a very popular thing. Let's go on to the matrices part on a new page. Can we be provided with a new page, kind sir? This is the easiest thing in my life. It's not. Let's do elements in the second column of B. What? An easy question. So the elements are second column of B. Columns are the vertical things. Columns, posts. So the elements are 3, 4, and 1. Find A inverse. Find A inverse. So if A is equal to negative 2, 0, 1, negative 2, A inverse is equal to, oh my gosh, we had to go through this whole shindig. Yeah, we had to go through that. The determinant of A, this is in the form A, B, C, D. So the determinant of A is AD minus BC, which is negative 2 by negative 2 minus 0 by some number, which is 0. So positive 4. Determinant is 4. Look at that. The adjoint of A is do the swappy daps of this and switch the signs on the B and the C. So negative 2, switch the signs. So this will be negative 1, 0. So the inverse of A, or you could put A inverse, is going to be 1 over the determinant by the adjoint. I forget to write the formula, but I could write it here. Which is, this time I'm going and multiply it because they literally asked me to find A inverse, so I don't want to leave it in this form. So 4 goes over everything. If I divide everything by 4, then what will happen? I'll get negative 1/2. I get negative 1/4. I get negative a half here, and I get 0 there, like A inverse. How was that? How was that for you? Show that A by A inverse is equal to I, where I is the identity matrix. Well, that's super simple, right? If you multiply a matrix by its inverse, you'll get the identity. So this is the original. What is this? Yeah, that is A. So you are trying to do A by A inverse, right? A by A inverse is equal to that. And the, what was I saying? I was saying something important. Oh, A inverse is, why we had to use them fractions for, boy? I will just track back to this part because all you want me to use the fractions, or I can just track back to this part. Let me use the fractions for one case so that people could see it, right? So negative half, it's easier to use this and then put the fraction in afterwards, which is what I've been doing when I'm doing these simultaneous equations. Negative a quarter and negative a half. So you do your matrix multiplication here. You get negative 2 by negative a half. Negative 2, half of 2 is 1, but the negatives will cancel, so I'll get 1. And so row by column, and then I have 0, 0 by, you all seen it? This by this, and then 0 by that. So anything with the 0 is just 0. And I'm going to do this part. It'll be 1 by negative a half, which is negative a half, and negative 2 by a negative a quarter is positive a half. So that will eventually work out to 0. Let's do this part now. So I get negative 2 by 0, which is 0, and then I get 0 by negative a half, which is 0. So 0 plus 0. And then for this bottom piece now, I'm not teaching matrix multiplication here because that's a whole 20 minutes. It's to teach it from scratch. So you could just look it up, matrix multiplication, Cohen Spring, and you could get taught if you don't know what's going on. 1 by 0 is that, and then negative 2 by negative a half is 1. So it's 0 plus 1. So in the end, we will work out with 1, 0, 0, 1, which is equal to the identity matrix, which is what I'm supposed to find. How was that? Another classic matrix question here. Matrix, how about we are looking extremely hard, eh? Like if you're watching this and you don't know what's going on, you're looking like you would never in a million years be able to learn this. But it's simple concepts we just applying all the time, over and over. You just need to learn the basics and you got to go. Determine the matrix BA. So I need to multiply B by A. That seems like too much of a headache. But you know how much multiplication is that? For 2 marks? Unbelievable. that is highway robbery. All right. Should I do that, or should I just pretend that that question doesn't exist? The things, boy, the things. I do an exam on Wednesday, and I could just leave that out. All right. Let me do it. BE. Let's do this on a new page. BE. This question make me use 3 page. Bad question. BA is like if I say negative 2, 0, 1, negative 2. All you better work out real nice now. Negative 1, 0. Hold up. Hold up. We have problems in the camp here. This is a trick question. B by A. Oh, I did it wrong way. I put A by B. I was not going to say this can't happen. Matrix multiplication could only happen in a certain way now, boy. Negative 1, 3. If you want to know the way, just look it up. Negative 2, 1. So it's B by A. Negative 2, 0, 1, negative 2. So let me just get a little insight on this. This matrix has 3 rows, 2 columns. So it's a 3 by 2 matrix. This matrix has 2 rows, 2 columns. These 2 numbers must be equal for matrix multiplication to occur. And the resulting matrix will be a 3 by 2 matrix. So it means in the end, I'll get a matrix looking like this. Diagonal. That wouldn't come for CXC. Not coming. Not coming. And I will say that with confidence. That's not coming. They wouldn't give you something this therapeutic for 2 marks. So what you could get multiple rows, more than 2 and thing, but there'll be column. So, but for those of you who are interested, how to do this? You'll take this by this, then this by this. That goes in the first spot. You understand? Then this by this by this by this. That goes in the second spot, and you keep repeating it for the rows. So you get this spot, this spot, this spot, this spot. Row by column. All right, enough of that. What is the size of the matrix product BA? It's a 3 by 2. And explain why matrix AB is not possible. I already explained. So if you try to multiply A by B, you'll be multiplying a 2 by 2 matrix by a 3 by 2 matrix. And since these numbers are not the same, it can't multiply. So how to put it in words? The number of columns in matrix A is not equal to the number of rows in matrix B, which is required for matrix multiplication. So the number of columns in the first matrix must be equal to the number of rows in the second matrix for matrix multiplication to occur. And all right, I feel to do one more question. One more question on slide 13, because this one have transformation matrix in it, which we didn't yet touch on. So the transformation matrix is given as that the point P, X, Y is mapped onto this point under T. Find the coordinates of P. So what they are telling us, this is basically a simultaneous equation in this, guys, and let me show you. They're telling us we take the transformation matrix and we hit it onto the point P. To transform our point, you need to take the transformation matrix and multiply by the point. And when we do that, we achieved P prime. So that's in letters. In numbers, we took T, which is negative 4, 0, 2, negative 1. We put it onto P, which is XY. You see in it? And we achieved 4, 0. And we must find XY. This is in the form AX is equal to B, X will be equal to A inverse of B. So you need to go ahead and find the inverse of that matrix, the inverse of the transformation matrix, which is T inverse. Find the determinant, find the adjoint. Do T inverse is equal to 1 over the determinant by the adjoint. We do 2 of this or 3 of this already. And once you find T inverse, multiply it by this matrix, the image. So you find the inverse and you multiply by the image and you'll get back the original object, the X, the XY. So I can leave that up for you all to do. Determine the transformation that maps P prime to P. So we just did that. That is the T inverse. That's the T inverse. So you just state that, right? Another transformation S is defined by the term by the matrix S. I already took the towel here. Another transformation S is defined by the matrix S. Find the single 2 by 2 combined transformation matrix of T followed by S. Oh. So T followed by S. Last little tip here that could collect you some marks in the exam. T, if they want you to do 2 transformation matrix in a row, T followed by S, it means you did T first and then you do S. So in the positioning, remember, this is the XY you're going to perform the transformation on. So in the positioning, T came first to this, then S. So when they say T followed by S, you need to multiply S by T. You understand? So you'll take 3, 8, 2, negative 1 and multiply by T, negative 4, 0, 2, negative 1. You'll get another 2 by 2 matrix. The answers that you get here is the combined transformation. So I'll leave in this question up to y'all. You can do it. We bring ourselves to the end here of our sessions, our 10 sessions. All these questions actually came from a book that I have called the Question Bank. You could just swing it for me. For those of y'all who are watching in the future, most of my class, I shouldn't say most, a lot of my class have the Question Bank and they use it for studying. So the Question Bank have a bunch of multiple choice, like 200 or something is basically the Question Bank for CSEC. It's basically all the different styles of multiple choice that come for CSEC. It has that. And it also is a top quality book. All my books, when I see them in the bookstore, best quality, good quality things, good things. They realize I do my things good, proper, all the lessons too. So what I'm saying, and it also has 5 sample papers based off of the last set of exams that CXC bringing. I may update it next year if the exam change up a lot, I may update this book next year to just keep on track with what the vibe CXC has. But we do have in stock. So if you're in Form 4 and you want to prepare for the exam really good, like with sample questions, daily book for you. 12-hour crash course tomorrow. Looking forward to that. Theory. Golden State playing tonight. For those of y'all who was in the live stream, you know the reference. If I feel well, I'm not going and see me again in the I'm coming on Monday to do some I'm coming on Monday to do some paper 2 revision too. But I ain't telling her about that yet. Let me see how my life looking after that 12-hour crash course. What else? Let me watch YouTube comments. Lend us your knowledge. If I used to get $1 million every time somebody tell me that, how many more sessions we get? Well, this is the final session in this series. So the series is done. But I am going to do some more teaching before Wednesday. On Monday. Look out for Monday. The WhatsApp group link. I don't have my phone on me. If all you have the WhatsApp group link, press the inviting and send it to the people now. What percentage is that one? Usually when you get above 75% total, you get one. Usually. But it changes from year to year. And it changes from subject to subject. No, I don't correct CXC papers. You'll find that most teachers like myself wouldn't venture into correcting CXC papers. Or if you do it once and then you stop. People who correct in your papers, this is something important to know. People who correct in your papers, most of the times, is not a big time seasoned super math teacher. It's not the math HOD in your school who doing maths for you, unless them feeling bored. The reason why is because CXC don't pay the people properly. If CXC used to pay well, more math teachers will feel inclined to go and correct papers. So sometimes you have not 200 people correcting your papers. I have seen some of the people who tell me they correct CXC maths papers, like, you correcting CXC maths papers. But they're supposed to have rubrics. They're supposed to have rubrics that these youngsters will follow. Which is why when I'm telling you all to do the thing a certain way, I want you to do it in the style that the Caribbean is accustomed to. So that when this UE graduate or somebody who just done or doing their bachelor's correcting your paper, and you didn't want that fancy thing, and they won't understand what you're doing, you ain't lost marks now. Remember to press like on the live. Yes, CXC is based in Barbados, but it's not only Barbados teachers correcting the papers. A good few of the teachers in the Student Hub correct papers. The Student Hub is the online school that I have. I have the same calculators as my teacher says I can't use it. With all due respect, your teacher is wrong. So don't let your teacher fight you down. I've seen teachers stop students from using legitimate scientific calculators. Just because, you know what? Go and look up Kerwin Springer Sharp. You realize the calculator, you think your teacher thinks that can't do what I show you that this calculator could do the same thing. So when I show students, this calculator could solve simultaneous equations, quadratic equation, the teacher like, oh my God, you're not supposed to be able to do that on a scientific calculator. It's true, you could do it on a scientific calculator. And even the same Sharp could do it too. But some teachers, unfortunately, they don't know about that. A scientific calculator and non-programmable, it in the syllabus. You need a non-programmable scientific calculator, which is what this is. Once you can like programming stuff and write out essays and things on your calculator and draw graphs and plot graphs and write out programming on your calculator, you're safe. It's a non-programmable scientific calculator. Don't let them fight you down. So how do I find the functions option? What? What do you mean by that? If you press mode on this calculator, you'll get all the different things that you could plug in. By the way, if you have this calculator, know how to reset it. Some people don't know how to reset the calculator. Shift 9 and then follow the instructions. 3, yes, AC. And it will come back to the normal mode. Because sometimes you go on in your calculator and you go on a mode and you don't know how to come back to the normal thing. That ever happened to you? And this calculator don't have a dedicated reset button in the back like the Sharp. So imagine you in the exam, you in some kind of weird mode and you don't know what to do. Tears. So one thing you can do is press mode and press 1. That's usually the normal mode. Make sure you calculate in degrees, people, not in radians. In maths, everything in degrees. Scroll back up there in them. I think the person says she said programmable. No, it's not programmable. Not programmable. Tell she won't make it programmable. And then show she D# could do the same thing. Love and blessings to all the people who send any loves and thank yous and thing. Yeah, I'll pray for you. But I'll make my prayers be with some salt, study. Don't have me praying for you and all your what magic tricks happen, eh? So someone asking about paper tree. Yeah, paper tree now coming up now. So I want to do in a little paper tree. But I mean, if you search Cohen Spring or paper tree, you'll see me doing paper trees. And if you study paper twos, you're studying paper trees. Paper tree is any topic in the exam. All right. There's lots and lots of videos on this channel that can help you. As I said, back in 2018, there was enough videos on the channel that hundreds of students text me afterwards and said they use the channel alone to study and they were able to get ones and things. So you can check out the different topics, and that's 2018, and I released so much more information since 2018. Just search the topic and my name, and you're good to go. Those of y'all in my class, you'll have extended videos you could go and watch on every single topic. So that's it, bye. Send the WhatsApp link. The WhatsApp link is also on the Discord channel. So if you go on, oh boy, I'll on Instagram. Just get my phone from Mr. Let me just send the WhatsApp link. I'll hold on a second for those of you who are asking for the WhatsApp link. I'll get my phone to send the WhatsApp link. Hold on, WhatsApp link is coming. Yeah, faithful Mitchell, that's true. Yeah, Tyson, good to always see you there. Take care. Oh, YouTube banning the link when you're sending it. Yeah, that is happening. YouTube telling us you can't send no link here, boy. YouTube saying don't send no link here. Let me see if I have it still copied. All right, I'll send the Discord link there. Let me see if I could send the CSEC class of 2023. That is real talk in this group, so all you know all you're getting into. All you gotta mute the group. Every time you're ready to study, you gotta mute this group. I think that should organize it. Tell me if you all see the link now. You see the link? Still at 358 all you here? Press like. So yeah, because you would go in that group, you would join that group, and in the next 2 hours you can see 1,000 chats. So you gotta mute the group. There's real talk. But it's really useful for a little updates and things now. So you can jump in and catch updates. Oh my gosh, look at people joining. Yeah, you'll find the link. All you did find the link. And don't do nothing naughty in the people them group. Love and blessings, people. It was good to have you all here with me for the 10 days. Take care.